In this tutorial, let's see what are subscripts in Swift language and what are the uses of subscripts. It, it might sound very new terminology, but this is what we use it in our daily life programming. Let's see. For example, I'm taking an array. So, as this is the native collection type, now we can access r of 0, where 0 being the index, which gives us what is the element at the 0th index, and same applies to at 0 1 2. At index 2 I have 3. Now i'm getting base I'm getting the element in an array based on the index, and also if I make it mutable I can assign it as well. If array of 2 is 2, I can change it to 12. Now if I see what is my array, now as you can see it is not sorry, at second index I have 3, I changed it to 12. Now instead of 3 I have it 12 here. That means based on the index in my collection I am able to get the element at the index, and I am able to set the element at the index too. The same thing we can do it for dictionaries as well. For example, let's say key value pairs. I'm taking a dictionary where name is let's say okay, let's say name is a string value, and id is 2, where id being a, this one, and as it is key value is string any, I need to explicitly typecast it, otherwise we'll get a error. Now this I can access it with the key value. For example, if I ask what is the value in the dictionary for a key named name, now if I can say okay, it will give name is this one. The same way as this dictionary is mutable I have given, I can change it to something else. Now if I print a dictionary instead of the name that I have initially given, now we should be able to see the dictionary values are got changed. So this dictionary and array are native types, so we're able to directly access based on the index or based on the key value pairs. Now what if you want to write our own this index based accessing or key based accessing in our own collection types? Now here comes the subscript subscript in Swift programming language, using which we can achieve this type of accessing, reading, getting, and setting in our collections. Now let me quickly get this subscript syntax, which is pretty much looks like an instance method where you give the proper where you give the let me take this and let me put it here, where you give the parameter, it returns something, and as well you can get it as well as set it the value. You can get it as well as you can set the value if it is mutable. Okay, forget about the error. The error is saying this should be used inside a class or a structure or an enum in Swift programming language. So this syntax looks like an instance method. Instance method will be having func, but it will not be having func, and it also looks like a computed property where you will be having the getters and setters, usually which we write in our models, structures, classes, or enums. We can write the computed properties. Now let's take an example and see how we can write the subscripts and what is the use of this subscripts. I'm deleting this, and let me keep this. I'm deleting this as well. Let me take a product which has name, which is of string, which has id, which is of int, which has price, which is of double. say for example, now uh, I have, this is the product. Now I have my shopping cart. Of course, to the shopping cart I can add a list of products which I can buy or I cannot. I can ignore, right? So which is, and my shopping cart may or may not have products. My shopping cart could be empty. That means this product could be empty. So that's the reason I have given it as optional. Whether I add my products to the shopping cart or not, it's optional. Now, for example, let's say shopping cart is equal to, let's say I've created the instance. Now, I want to access the first product in my shopping cart. Now, how can I access it? Now, usually what I do, I just get product at index, right? Index, you give some int and which should give you product, which is an option. Why? Because you might be or might not be having a product. Now let's say for example, to avoid this error, I'm returning nil. Now I need to do this at 0. So with and also if I need to set a product, for example, I create my product instance and I want to, which doesn't need to give me anything. Sorry about that. Setting the product. Now okay. Now products of uh, index is equal to product at index. Let's say products of index is equal to product. So this is something I need to do. Okay. Okay, this is something I need to do if I want to get my product in my in the in my shopping cart, which is having a collection of products, and this I need to set a product. So again, if I need to set product, I need to create an instance and I need to, okay, this is creating a self is mutable. So the point is get product, set product. So this is what we need to do. This is the usual process. So we can avoid this. What if it is something like, okay, I need shopping cart of 0. So this itself is saying like, okay, this is the shopping cart index. He's looking for a product at index 0, right? Or uh, or let's say this is the shopping cart index and he is looking for an iPhone. If it is available, okay, you give me the product instance. If it is not available, take it. Okay, that's fine, right? So we can achieve, instead of this, this is very looks very native style, and it, pretty much readable also. So we avoid this, we don't do this. What we do is we write subscript. Okay, subscript, what you pass. Okay, I pass index basically. Now what you do, now I do this, you give me whether I need this or not. I call this, okay, you return me this. Okay, now I as I'm having both as I want to have both getter and setter. Now what I am doing is, now get, if I have to get what what I need to do is products of, it's as simple as return products of index if it exists, else you return it. If it is there, if at index it is available, pass this, otherwise return nil. It is as simple as that. That means this first this product should not be nil, and at this index there should be an item. So this is how we can return. Next, to set it, for example, I want to set something. Now what I can do is products of index is equal to this. Automatically the default by default, uh, this is the default value that comes when you are setting something. So what I do, I pass like this. Okay, now instead of doing all these things, I'm just writing my subscript where I'm passing the index. If you need something, okay, this is something. Okay, new value. If new value is nil, default value, let it be nil. That's not a problem. So the point here I want to convey is, instead of writing these many functions, you write a subscript where you get it, where you set it, and using the index you get it, you set the new product value, it sets that into the products, right? So now it is as simple as, for example, let me take, okay, let's force and that's not a problem. Now let me take couple of products here. Product iPhone 1, 200, price is double, that's fine. Next, what is iPad, let's say 300, ID is 2. Let me take one more product, iMac, let's say 3, let's say it is 500. Now sc dot products, I'm assigning it is equal to, no, it's just an array. No, we're good. Now I want to access, if I say sc dot 1 means the product at index 1, this is 0, this is 1, this is 2, the product index this one, right? If I run it, what you see is, of course, it's a product dot name. It will be option, the optional chaining will be used. Why? Because the getter we have set it as nil. Okay, so it will print its iPad at index 1, the name of the product is iPad. Now I want to change it, which I can pretty much, for example, instead of at index 2 I have iMac, I want to change it. Name, instead of iMac, I just want to change it as, let's say, Apple Watch. Okay, now let's see, right? The name is iPad. At 2 I have changed the name to Apple Watch. Now if you again try to access Apple Watch, see, now it's very handy, very easy, very readable. Shopping cart at index 1, what I have, I'm changing this, I'm changing this. Now I can access like this. I don't need to write multiple methods like this. Not only this, for example, I can use subscript overloading as well. Let's see what is that. Instead of passing the index, I'll pass you iPhone, the name of the product. You give me the product if it exists. It's, let's write it again, subscript. Now I am passing name of the product. Okay, again it's an optional, you give me if it has. Now I'm just writing the get here, so I'm not writing get and set. I'll omit set, I'll just simply get it. Now what I say is, now I have a collection. Now I need to use some functional programming. Why? Because in the products I need to search whether I have name or not. If it is indexed directly, as this is also products is also collection, I can directly go ahead and access something like this. But now I need to search which one is having. So I will do something like product uh, first index where this is my product, where let's go with contains. Here what I'm doing is I've got a name, name dot lowercase, let's say. First I'll write the code, then I'll explain what I'm doing. Return product of index. Okay, first what I'm doing is in this product, just a second. Okay, first what I'm doing is in this products array I'm getting the first index using the functional programming, first index of the product whose name at least containing the name I am passing, at least at least containing. Instead of course I can do a string comparison also. I can write is equal to, but first I am fetching the index. Of course this index could be uh, could be nil also. Why? Because it may contain or may not contain. So I go with if let. Okay, if let this, then I would say return products of index, otherwise return nil. If I have the index, that means if this name is matching with any of the products, then go ahead and fetch the index and give it to me, otherwise pass me nil. So this is called subscript overloading. If I pass integer values, this subscript will call. If I pass string value, if I pass a name, so this subscript will be called. Now let's see how we can access it. Now we don't need these many methods and this stuff when we are dealing with the collections. Let's use the subscripts, which you're seeing how useful it is and how easy it is. Now I can, what I will pass is get me the product which is having let iPhone is equal to SE of iPhone. Now I'll print this name. Of course this is an option, but see, yes, I have product name called iPhone. For example, now if I try for Apple Watch, meaning I'll pass, do you have something called Apple Watch? This, if you see this, this will be nil. Why? Because the shopping cart doesn't have any product whose name is Apple Watch, right? So if I ask like this goes to this subscript. If I ask like this goes to this subscript. Not only this, you can have subscript with multiple parameters also. For example, uh, get me all the products whose name contains this and price whose price is something like this. So like this also we can extend it, so that this subscript will return you the products which are containing this name and price which is equal to this. So subscript overloading applies here. See, that's how it is very useful. Why? Because if you access something like this, you can clearly understand, okay, shopping cart, we are accessing iPhone. Shopping cart, we are accessing Apple Watch. Shopping cart, uh, we are accessing the product which is at the first index. Okay, that's the use of subscripts in Swift programming language. Not only on instances, see this subscripts, now I can apply only on instances. We have type subscripts also, where we know what are type methods, type properties, where you use static, and for classes you use class also, right? So let's say I have an enum called weekdays, case Sunday, case Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, Tuesday, sorry. Wednesday, Thursday, Friday, Saturday. Now let's say these are all I access with the int, and Sunday I'm giving it as one. So Monday goes to Tuesday 3, something like that. Okay. Now let me delete declaration. Now inside this also I can write subscript whose index is int, which gives you same weekdays. It can be weekday, weekday. So simple getter I am writing, return enums raw value of index if it exists. If it's null, you return nil. As simple as that. So here I am writing type subscript. That means this we don't need an instance of this enum directly. So our idea is, if I pass 1, what I would expect is Sunday. If I pass 2, what I would expect is Tuesday. Why? Because these are weekdays. I don't need to create an instance of this enum. All I need is, on this type I want to add subscript. So if you can look at it, I'm not creating any instance of this enum. I'm writing it directly on the enum type. So weekday of 2, if I say, it should give me Monday. Let's say, see, now I have got Monday. Weekday of 4 is should be Thursday, right? So these are uh, these are type subscripts, which using static, instead of creating an instance, you can directly apply it on the type. These are type subscripts. These are subscripts. This calling this and calling this, these two, when there are two, so what gets applied is subscript overloading. So based on what is the parameter you are passing, that particular subscript will be called, and it can have a getter and a setter as well. The getter and setter, this format is similar to the computed property. Subscript is like a function, but it will not have normal instance method related syntax. It will not have func and all. Okay, I hope this post is useful. Thank you.